Intel Triton Intel GPU upstream. So for us, like we want to get like a PyTorch requirement on like what exactly is needed. Like so, from Nikita's point of view, it seems like PyTorch could just get the Intel Triton from like a separate GitHub or separate branch for the CI purpose. So I think that one we want to discuss here in this forum also. Then for the release support, Phil agreed that the Intel GPU could be part of Triton official release in case PyTorch made the Intel GPU part of official release also. That's the current status. Yeah, basically, we want to like use this meeting also get the PyTorch's input, like what is the what is your requirement from your side that Intel Triton should be like in what kind of like a status so that you can consume it to support your CI.
Yeah, Nikita, go ahead.
Yeah, maybe we should start with the purpose of this meeting, because I don't think anything that PyTorch wants or doesn't want to do for CI have any relevance to Triton, like ecosystem in general. So I would prefer to keep those maybe separate. Like it would be good, like as just a developer, it would be good to have one Triton, like one version of Triton that is compatible with all accelerators. But I don't think that precludes like want to build Triton separately for different accelerators. So let's keep those discussions separate. Just like my 2 cents. Thank you.
So Zhenhui, you can give an update on what the current status for Intel is, and then if you have any questions for the PyTorch team, we can discuss them more.
Yeah, so from us, we are able to support the PyTorch end-to-end models. So basically passing all Triton function units, and also we're up to date with the current Triton ahead. So the issue is mainly like when we talk about like a Triton inter-GPU integration. So when Triton consume Intel, like Triton, PyTorch consume Triton to support CI and then release. So what exactly is the steps? The issues comes like when, for example, PyTorch choose a Triton commit point, and then sometimes if we leave out of tree, then we have this issue that you know we are not that commit point does not work with us when we build with PyTorch. So if PyTorch side it confirmed that we can like continue to do this like as a fork or as a separate branch, then we can live with that.
Sorry, is the question? Oh, sorry. Who has a hand raised? Justin?
I just wanted to check if we had anything related to Triton to discuss, because if not, I was going to sign off.
I mean, I think this is kind of related to Triton, and the question, if I understand correctly, is we want to make Intel part of the release in case it can be integrated into PyTorch, and I think that's the question is yes. How do we get there?
Right, which is a question for the PyTorch community meeting or something, right?
Sure, I mean, that's one way to see it. But yeah, I think
Or if we want to discuss it now, that's fine. I'm a Triton developer, so I'm happy to sign off if we don't have anything related to Triton to discuss at this meeting.
So after this, after the Intel update, we have the profiler update by Karen, and then we have the AMD update, which would be directly related to Triton.
Maybe wondering if we could do the things related to Triton development at the Triton community meeting first, and then if people want to stay on and talk about PyTorch, sure.
Yeah, so the reason we pulled this item up front was because some of the PyTorch folks need to drop at half an hour mark. So that's why we wanted to discuss this earlier.
The question's been asked like 3 times, and so far the PyTorch people haven't been interested in responding. So maybe this is still the wrong forum for them. Can we open it up one more time? PyTorch people, do you have anything to say to this?
So I think I also maybe that's the first time I attend this meeting. So I also don't understand what are we trying to achieve in this forum. I agree we should discuss something related to Triton, and we should keep discussion about how to in the long run, if Intel GPUs are supported by Triton, that will be a great outcome. And if we can work towards that goal in this meeting, that will be a great goal in my mind. In the short term, I kind of doesn't matter what will happen. I think so.
I think
you guys agree?
I think the stance from the Triton team is we will happily that Intel will be in the release if and only if there's this requirement, if and only if the criteria related to PyTorch are resolved.
Right.
That's sort of what.
That's a missing context maybe for Nikita. Was that the goal really of the criteria to have Intel as part of the release was whether PyTorch was going to be able to use it, and that's why maybe the discussion's a bit confusing. And
okay, I think it's a chicken and egg problem. We don't know whether we'll be able to use it until we see how it's implemented, right? So there should be a development branch. Before we talk about merging, I think we talk about features before we look at the code. We have a dev branch. We look how this dev branch works. We can talk about upstreaming it, right, or merging it into Triton. Until I see as far as I understand, XPUs are somewhat different from GPUs, so that will require some changes to the Triton IR or ML IR. I don't know, and that's I guess a discussion to have.
To be clear, the code is not going to be merged into Triton. It's going to be part of the release, but is not going to be merged into mainline Triton. That's because we have had a lot of bad experiences merging backends into Triton. So this was the compromise. Intel wanted it merged into mainline Triton, and Phil said, we're not comfortable doing that at this time, but as a compromise, we're willing to make it part of the release.
Which shouldn't affect PyTorch really. That should not make a significant difference.
But it sounds like you and the Intel people, whoever is responsible on the PyTorch side and the Intel people need to sit down and figure out, can we use this thing? What do we need in order to use it? Maybe you'll come back and say, you know what, we can't use this unless it's merged into mainline Triton. I don't know.
So that doesn't sound like an answer. If AMD is any example, we want to move. So thank you very much for integrating AMD as a backend and include it into your main release, but we're not there yet to use it. So we use a different forks and different commit pins for, say, AMD binaries and NVIDIA binaries. And so we use 2 builds of Triton. For the same reason, I don't think that Intel XPUs will be part of, say, CUDA release or ROCm release. So I don't see a problem of building it from the development branch. So I don't necessarily see, again, as I said at the beginning, it would be nice to have it eventually. From at least CI/CD point of view, I don't see any reason why it should be if you guys saying that you cannot test it right now, then I don't see the reason why it should be in the main branch of or make it part of the same release as the rest of the Triton. I don't think who it will help. Maybe I'm missing something.
So it sounds like you're saying that if Intel wants a PyTorch plus Triton release that works on Intel GPUs, you can build that in exactly the same way that you build AMD, which actually does not use the upstreamed AMD GPU. So actually,
Not
Sounds
yet,
like
yes.
Intel doesn't need anything from Triton, doesn't even need Intel GPUs to be included in the release in order for it to be part of PyTorch.
Oh, so from CI/CD point of view, yes. I guess from the Triton language point of view, maybe they need, but I'm not an expert to speak here. They need some language features to be considered for Triton, but this is not the case if we're not discussing like a new primitives or whatever that is needed to express some parallelism on Intel GPUs. And yeah.
Cool. So Jianhui, are you happy with that to work with them?
Yeah. So it's a good clarification. Nikita, for the CI/CD, yeah, you said that we could use a separate branch. But for the release, the binary, you post in like Anaconda or those like, do you think does it also require us to put into a like a Triton official Triton release, or you do not care?
So there's no Triton on Anaconda, so I'm not sure what you call an official Triton release on Anaconda.
Like a pip install. Like
for PyPy,
IP.
there's also only NVIDIA. There is no yet ROCm, like, correct me if I'm wrong, there is no PyPy release of Tritons that supports both AMD and NVIDIA GPUs.
But that's I mean, that will be the next one
Correct.
would support
Correct,
AMD.
and hopefully we will be able to use it, but I don't know, maybe that's the second part of the discussion if we're there yet, right? Because I think there's still some like performance regressions and whatever that people believe that using a fork is still beneficial, but I hope as like a maintainer it will change and we can use one. So yes, I don't think there's any requirements. Again, hardware accelerators right now are mutually exclusive. You cannot build PyTorch with NVIDIA and AMD GPU support at the same time. Very unlikely you'll be able to build PyTorch with NVIDIA and Intel GPU support at the same time. So I'm not sure where the problem is here. Like, you need to build separate binaries for separate accelerators. Right now, that's given. If we can move in a long run to a situation when we have one binary, this is great, but I don't think it's a pressing matter. Yes, it would be nicer to have like some sort of a regression testing of new features of upstream Triton on Intel GPUs. If this can somehow be achieved, I'll be happy about that, but that's unrelated to PyTorch. It just makes the upgrade process easier.
Okay, so it sounds like yeah, Intel and PyTorch team needs to work together to figure out how to get at least to the same place where AMD is. And I think we can resume the discussion after that about, yeah, getting everything into like one wheel and etc.
Yeah, thanks.
Okay, sounds good.
Yeah, thanks, Jayanhui. Thanks, Nikita. Karen, do you want to go ahead with the profiler update?
I think AMD guys can go announce their updates first. I don't want to delay them.
Okay, Jason.
Hello. Yeah, so kind of relevant topic though. We're going to give a quick update on the AMD backend. Might help on some of the conversations going forward. But as a side though, on our PyTorch integration, we still kind of have to manage that separately as well, right? So we have all of our kind of support in upstream at the moment, but as was mentioned, there's we're still kind of working through a few regressions and a few performance things, and with Torch we want best of the best, and there's a whole regression suites in Torch that are very important, right? So it's even for us it's a kind of like a managed thing for now. We have goals of getting everything that's in the upstream, like the sole source of truth for AMD support. But it was a bit of a change from a couple of the different backend plugin models to where we are now. We like where it is now, but we did have some things that were in the front end that we can't do now. So we're working through things. We had to move some of that into the back end, and it's a bit of a process. So yeah, so which is fine. We'll get there. I think everybody will get there. I think this model will work. I can maybe show you some of the important bits though. If I could just share some of the code here. If we look in the GitHub, 1 second, just to share my screen. One sec, here we go. So this is just the third-party backend AMD directory. If you've not seen this, I'll just a quick walkthrough of where we're at. This is all functional at the moment and just builds together if you've got ROCm support on the platform. Kind of one of the interesting pieces of the new model is we can we have our own compiler.py and allows us to do all of our specific hardware settings here, and this kind of makes a lot of sense for the because you know invariably as close as we are to NVIDIA's backend, like we share everything up until we do some differences on the GPU IR, but even as close as we are there, there's a number of settings here that we need to do for our platform, right? So there's and we're able to just kind of plop it all into this file, and it's all in the back end, and it's just kind of lays on top of what's already there in Triton. So, you know, so we have like kind of different FP8 types and things, and we can kind of get things enabled in here as well from top level point of view. Like we have like some hardware specific settings like this wave per EU setting that we can put defaults for, and then we can kind of, you know, plumb those in as well, just at this Python layer all the way up at the top. So the other kind of neat thing is we can customize the passes, right? So one of the other differences, like a lot of our passes end up being the same up until the GPU IR layer, and at that layer, at that point, we can kind of customize some of the other things that we can add our own passes in here at that point, and this is all controlled from our compiler.py, and it just kind of lays over what's already there. Which actually works nice. So before in our previous implementation, we would, you know, we had everything kind of zippered up functionality wise, where we had at the Python layer, we just have if hip checks, and then at the C layer, we'd have if def defines throughout the code. We don't have to do that anymore. So, which is nice. It makes it cleaner from this point of view, and then makes it cleaner from the backend point of view as well. So, yeah, and then we've got some specific kernel level things that we can add in as well. And these just kind of map directly to LLVM APIs on the C backend. So, you know, we can set, these are all AMD specific namespace settings in LLVM that we can do. So, so that's kind of neat level, high level control of our backend. And then on our lib side, you know, we only have kind of 2 directories here, and this is all down at the AMD GPU IR layers where we have differences. And so some of this, we still have some duplications here. Phil and Upstream have continually trying to rework and refactor some at this layer even. And this, you know, not just to help the AMD backend, this will help all the backends, I think, if we can kind of, you know, change it to a point where you know, we don't have to have a lot of duplicate code, and some duplicate code is actually fine, really, because you know if it's in the right domain, like we are controlling this, we could be informed by the NVIDIA side perhaps, or you know, maybe we can take it and go our own way with it. We don't want to be completely constrained by no duplication whatsoever, but as it is right now, this is mostly a duplication of what's in the Triton GPU to LVM directory on the NVIDIA side. So I think we'll probably eventually have a little bit less differences throughout on this side, but this is kind of where the bulk of our backend ends up being. And you know, a lot of the changes end up being you know, in our matrix core stuff versus NVIDIA's tensor core. And then in transforms, we've got a few different optimizations and changes as well for specifics to our platform as well. So so the code base overall, the code base ends up a lot smaller, which is good. Like the front end ends up completely out of our hands. Like we did have some things that I mentioned where we were promoting certain lower precision types, for example, for certain operations, and we would just kind of handle that all on the front end. Since front end is kind of off limits now, that's one of the things we're moving to the back end. We'll have an extra pass that we've added to, for certain cases we need to do that promotion. So that's one of the things we're working on right now. We'll get upstream here shortly. So we'll fix up all some of the unit tests that have been failing since we've got all this merged in. So that's really kind of it. We do like this new format, this new model. Just from a working point of view, it's cleaner, right? So we can, we've noticed some of the ops that we didn't have in our fork that were new. Just work now. We didn't even have to merge anything in. We don't have to maintain the code base. It's just kind of there. Some of the things that were some of the new ops, like the histogram thing, we need to go back and look at. But a lot of things that are kind of front end based just kind of work, so which is great. So there's less maintenance overall, and this will probably go for others that are conforming to the same kind of back end model. But yeah, so that's it. I think with the community, like the CI in the upstream repo for AMD is a work in progress. We had something there, but we need to make sure it's as secure as possible with the external runners. There's all sorts of gotchas there. So we're interested in if others have ideas on setting up secure community runners, and maybe we can collaborate on that, like a proper way of doing that once we've got other code bases in as well, because we want to make sure the code is protected, but then we want to make sure like the runners are protected, right? We can't have people hijacking things, and third-party external runners are prime targets. So open for like maybe a separate call or topic, and come to working through that if anybody's interested. So yeah, that's kind of mostly our update. We do have a kind of updated list of everything that's working. We're looking pretty good now on functionality point of view. We'll be quickly moving to the phase of like comparing our fork that we've had to the performance on this one, and then we'll kind of have this next phase where we tune it up. So yep, looking forward to that, and look forward to sharing some more results once we get there. But yeah, I think that's what I've got for today.
Thanks, Jason. Any questions for Jason?
Yeah, I do have that too. You mentioned that in the lib there's the Triton GPU to LLVM portion of the conversion patterns that are currently still a lot of duplication with the NVIDIA version. Do you see, is it sometimes you have to compare to those files and find out what's new and then update it, port the changes accordingly? Like if that happens, how often does that happen? And the second one is, I can leave the second one after your answer.
Okay, yeah, I'll quickly address that. But there is, right? So and there's still maintenance, obviously, right? So like we had, but it is much reduced from maintaining our own fork, and then updating the AMD specifics that were involved in that. Right now it's just kind of this directory where we do that, and so we do. So we're kind of evolving this, but we've got a rotation where we call like an upstream watcher, where we're in the upstream commits are frequent, but not frequent to the point where it'll overrun someone's job for the week. But we'll kind of have this rotating duty. We'll have an upstream watcher, and things that come in and hit each of these, and a lot of times that we can merge things in pretty easily and keep rolling. Other times then we got to look at it a little closer. But yeah, so there's reduced maintenance overall, but it's not down to nothing by any means. On the duplication stuff, which is something we got to keep watching.
And when you like compare the file, do you do like a file comparison, or there's something better that you do to make sure you get the latest changes?
Well, so it's usually, so we do like the watching duty. So we'll like as commits come in and are adding function to like the NVIDIA backend, for example, because what was mostly what we're tracking, because that's the latest and greatest, right? So we'll track it from like the commit and from the functional point of view, and then we'll roll it down, to our side as we need. So it's at the end of the day, you're doing probably code and line comparisons, but even though there's a lot of duplicate code here, they're not perfect, and like a git merge won't apply because they're different files in a different directory.
Right, exactly.
Git magic, right? So, so you know, it's just kind of like, you know, you know, kind of like a functional based compare first and foremost, and then we'll go and add what we need. And the volume is not enough where that's unbearable at this point. So, you know, we'll see how we go if we need to adjust anything like that. But so far it's been okay.
Okay. I don't know if Ettore have a comment on the first question.
Yeah, it's a follow-up question about this. So we're doing a little bit. So there is obviously duplication of code. That's the main issue here. You know, so that if somebody in OpenAI go and fix a bug in some of the LLVM code that can be used by other vendor because it's agnostic to the target architecture, then you don't get immediately that fix, and you have to backport it to your own copy of that file. And it all stems from the fact that we all know that duplication of code is evil. I mean, I heard somebody tell it's not the ideal situation where you want to be. So I wonder if there are, here is an idea. So what we do for the Intel port, we don't do the same thing. We actually pass a target architecture around while the code is being lowered, so that you can always create a switch on the target architecture to say, well, this is a portion of this function, this conversion pattern that is different for AMD compared to OpenAI, compared to NVIDIA, compared to whatever vendor. And then, you know, you can switch on the target architecture and still benefit from all the remaining code around that is common to every vendor. So I guess that would, if OpenAI was open, if you guys were open to do it that way, then the vendor would not have to.
I can just interrupt you and say we're not open to doing it that way at the moment. That's why it's being done this way. Thanks for the idea.
Okay, so there is in progress.
Like I said before, I think, you know, and you're right, duplication is bad, but sometimes duplication is all bad, right? Like duplication is bad because you can, you know, you get a maintenance burden, but you know, we've signed up for that on our side, right? So, but it also gives us a little bit of freedom in this layer if we needed it. Like it's up to us to you know, get those backend changes in if we needed them, or not, or change the code a little bit, right? So it's you maybe don't look at it as a duplication, maybe look at it just very similar, right? So, and it's our job to maintain this for the AMD backend, and we'll continue to do that.
Okay, just
and if you know, Phil's also kind of doing a little bit of restructuring to try to minimize this, because it's, you know, there's still some things that we can do and that Phil's doing, and that's great. So, and we'll continue to work on that as well.
So to the previous question, comment, can I have a follow-up? Like you say, OpenAI is not open to this. I understand the statement. Is that a statement at this point in time we are not open, or this is like long-term, we're not open to this at all?
It's a statement about, oh, go ahead, Thomas.
Yeah, sorry, just I was going to, guess give you a little bit of like updates on what's our plan, which we are actually doing some refactoring right now. Zai, I don't know if he's on the call, is working on some refactoring, especially related to some of the duplicated code. It won't remove all of it, but I guess I can tell you what we're doing, and maybe that will, you can tell us whether you think it's going to work out well for you or not. A lot of those patterns, especially in the convert to LLVM, the goal is to separate out what is going to be platform agnostic to platform specific. And we do know that a lot of the patterns, like we can convert them to LLVM the same way for any kind of target. For instance, if you look at like the element-wise, a lot of the patterns, we just take the Triton GPU IR operations, and we convert it to the equivalent LLVM one. And the goal is to take all those patterns, move them in a common area, and then you can build your own Triton GPU to LLVM paths by adding all those populate calls that will populate all the right patterns for you, and you can mix this way whatever you like, target specific patterns you have with the target agnostic patterns you have. And this way we are hoping a lot of the duplicated code can go away. I think the next step, if we want to go one step further on reducing code duplication is to parameterize a little bit those patterns to allow like some slight variation based on targets.
Okay, so that I think that's I personally think that's a good plan.
I think that's a good plan as well. And then you got to see some of that same idea with that with the compiler.py. I was looking at, we were showing you where we can kind of define our own set of passes, right? So if we one of the things that's different for us is the pipeliner. You know, we've got a separate pipeliner feature that can do streaming in for, you know, for our specific architecture works well. But that, you know, so we're able to add that pass in on our compiler.py in our backend, right? So this is kind of like, you know, this works the same way, and this will be nice. We can kind of just you know, componentize things, build it together. Makes a lot of sense.
Yeah, I agree. And then my second question is, how often do you see you have to make changes out of the third-party AMD file? Do you ever have to do that?
In third-party AMD directory? Which file? Or
like, I mean, outside of the third-party AMD.
Oh, you mean like this? So if there's something in the front end that we needed. So far, like, when we obviously we want to avoid that. If there's certain things that we end up needing, we've got to raise that as a need, right? And then we can discuss that, you know, with the OpenAI guys if we need it. So far, we've not needed to. It's set up in a way that's worked so far. Like the one things that we did have to end up doing a little bit more work was that type promotion that I mentioned, which is kind of a hardware specific for us. We wanted to promote certain types at certain times, and it was easy to do that in the front end. But you know, in our front end, or in the front end for that's upstream now, like it doesn't make sense to do that for everyone, right? And we don't want ugly switches in there too. But so that's something we can do in the back end in the specific case anyway. So we're fine with doing that. So probably a lot of times if we think hard enough, there's something in the front end that we needed to change, we probably can do it in the back end if we needed to, right? So that's how we're approaching it. So far that's worked. So.
Okay, I see. Because one example came into my mind now is the math.py with our in Intel the function calls, the device function calls different names. So maybe those files need to be changed in a common area, or maybe the math.py have to be specialized in all the backend, something like that.
Yeah, I suspect there'd be a way to specialize that as well if you needed customizations there. Yeah, and maybe so. Yeah, I mean, maybe there is other things that could be componentized with the front end, but that'll be as you identify them for your stuff. And it's just a conversation that'll need to be had, and maybe there's a a quick way of doing that without changing much or if at all with the front end code. So yeah, but yeah, as you go, if you're complying to the new model, you know, just would recommend trying to minimize that as much as possible. There's a lot of times you can think of ways around that, but with that one, I don't know. You'd have to kind of talk with Phil, I think.
Okay, thanks for sharing your experience.
Sure. Yeah, no problem.
I just want to add one thing from the kind of OpenAI perspective about all of this, which is that we've sort of tried it both ways. We've tried the way of like putting a bunch of if statements inside of the code, and that doesn't really work. So there was a big refactoring of the front end where like, and this is nothing against AMD, this was the way AMD had to do it, but like AMD added a whole bunch of if statements into the front end. And that was bad enough, but you can imagine then adding a bunch of if statements for Intel and for whatever other backends that you're trying to write. Some backends are even out of tree. So that's part of the motivation towards making things modular so that you don't have to sort of carry a whole variable down into every single function in the code that says what backend am I, and then you have if statements everywhere in the code. Yeah. So we don't want to do that again.
Well, and I agree. I mean, the changes that Phil did to the front end are very useful and actually much better because, yes, exactly the problem that you mentioned. The front end has been sort of taken care. Now is in better shape. Following the same or similar strategy for the backend code, it would definitely make porting the project to other vendor and architecture easier. So the idea of componentized things and parameterized passes, I personally think that's a very good design.
It'll just take us some time to get there.
Yeah,
Yeah.
no, for sure. Yeah. And as we talk as a community and try to, talk about things that work and things that, maybe we need to slightly adjust, that I think that will help. Give OpenAI the most feedback as they can, so we can all succeed, right? So.
Okay. Thanks, Jason. So let's move on to Karen for the profile update.
Sure, let me find my screen. Can you see the screen now?
Yeah, we can see it.
Okay, good. So today I'm happy to share a project we have been working on for a while. Actually, it has been used internally at OpenAI, but since we want to open source it, we actually refactor it and make a version that can be used for probably all the outside community. So Proton is the name of for this profiler, which stands a profiler for Triton, another element in chemistry. So the goal of this profiler is to provide a quick, intuitive, and simple way to check kernel performance. It's going to be open source, and it will support multiple vendor GPUs, and we want to support flexible metric collection, including hardware metrics and software metrics. And we want the default profile view of this profiler be call path profiling. So here's two examples of call path profiling. In the first example, we are going to collect Python call path of every GPU kernel invoked in a PyTorch script from the root to where the call path, including every Python file triggered. And you can also define a custom context through some instrumentation utilities provided in Proton. Just feel free to interrupt me if you do have any questions. For example, we can annotate a scope of code with backward and forward, then it's going to profile and list all the GPU kernels underneath. So the metrics we are showing here is the kernel running time. Here's the design of Proton. It's going to support both a command line utility and the instrumentation-based utility. The command line utility will use LD audit to instrument the load library and whatever to get started profiling. And for instrumentation utility, it's going to annotate your code and start profiling as you annotate it. And all those functionalities will communicate with the underlying profiling interface through a C++ library. So our plan is to support NVIDIA and AMD GPUs at first, uses NVIDIA's Capti API and AMD's Spark Tracer API. And once we export what we profiled, we want to support multiple formats, including EasyView, which is a profiler in VS Code, Hatchet, which is something we just show here that can show a call path profile view on the terminal. And also, if users want to collect trees, then we can probably export JSON format that support trees. So here's the design of the profiling library. So for each GPU kernel launch, we're going to intercept this call on the CPU end. Then we're going to record a external correlation ID for this kernel launch. Then it's going to represent the execution of this Triton kernel on the GPU using profiling API such as Capti. It can correlate the external ID with kernel metrics, so that after we gathering enough kernel metrics, we're going to flash it from the device to the CPU. Then we're going to correlate the call path we collected with metrics we collected. When aggregating those metrics like timing, we're using grouping functions like mini, max, mean, and standard deviation, and group them into call paths with the same name. So here are user interfaces we want to provide, divided into two categories, including lightweight instrumentation and command line utility. They are going to be, some of them will be compatible with Torch Inductor. So to get your profiling gets started, the most simple way would be just annotate profile.start from the place you want to get started profiling. And once the execution is done, you will be needing to call profile proton.finalize to write the profile onto the disk. You may want to skip some regions, but still accumulate to the same profile. That's doable with Proton. It's not doable with Insight systems though. So you can get started profiling, then it's going to return a session ID. Then using this session ID, you can deactivate profiling, saying that I want to stop profiling for this version of code. Then you can reactivate profiling later. So you can also start multiple sessions so that you can profile all the metrics and aggregate into different kind of fields, like the tree view we just showed, or you can aggregate into trace view. So here's the scope functionality, which you can use to annotate version of code. In this example, we have nested scopes from test 0 to test 1 to the function we called underneath. Then this is the profile field we showed on terminal. You can see that from the root node, we have test 0 underneath, following by test 1, and following the Triton kernel, which is called. So we also have a metrics utility, which users can use on the Python level. There are two kinds of metrics we want to collect. For asynchronous metrics, they're going to come from the profiler. This is something users don't have control with. But for synchronous metrics, they will be annotated and provided by users. They can provide things like the theoretical flops and bytes for this Triton function or region of PyTorch functions, or the loss that's going to get at this step, or the count of kernels or modules have been invoked. Essentially, what users need to provide is a dictionary with matrix name and the metric value in either integer or float. So here's the example where users can provide his metrics. Those metrics, like the hardware metrics, will be aggregated into this scope. So the user may want to denote this scope, which has a single Triton function with test 0, then providing the metrics to this scope, which is full metric 1.0. Then during execution, we're going to aggregate all the full metrics once we execute this full function. Then after that, when we check out the final profile database, we can see there are multiple metrics available in this profile data. We have the count of the kernel, the elapsed time of the kernel, and the full metrics, which is the software metrics we just defined. And two metrics, for now, two metrics can be displayed at the same time. We also support renaming of Triton kernels, where you can demangle the Triton name and append custom names as needed. For example, you can append launch configurations, like what's the grade size you use, what's the number of verbs you use. You can append runtime dynamics, like from which branch you invoke this kernel, and you can also apply constants. For example, here we have used fast math in this Triton kernel, then you can just append it to customize the Triton kernel name. It can be used together in a format as context manager with metrics collection. Beyond that, we also offer decorators with metrics and renaming, which are less intrusive than context managers. Basically, you just need to annotate your Triton kernels with proton.metrics or proton.rename with the rename function or metrics function you want to use. For example, for metrics callback, by default, it's going to provide you the grade size, number of verbs, number of CTAs, the dimension of clusters, shared memory, stream, function, metadata, and all the arguments passed into this Triton function. In this function, what you have to return is a dictionary of metrics and the metrics values associated with different metrics. For renaming function, it's going to accept the same arguments, but you need to return a string representing what kind of name you want to provide for this Triton function. So here's our plan. The next step would be integrate into Triton. It will be provided under the third-party library. It's not gonna be installed by default. You probably need to clone the Triton repo and install it manually. And the next big thing is to support AMD GPUs. For now, only NVIDIA GPUs is supported. Then we want to develop command line user interfaces. We want to provide fine-grained metrics like instruction samples and binary instrumentation-based metrics. We also want to integrate this tool with VS Code. That's it for the presentation.
So question, we say supporting AMD GPUs, will you do it in a way that in the future it could be extensible to cover Intel GPUs?
Yes, the major problem is that we don't have any Intel GPUs yet, but feel free to donate if you do want.
Okay, yeah, for the, there is, like, but in general, I was asking your software design, like, that do you, like when you design, you have that kind of extension mechanism in your mind so that
Yes.
any kind of backend could be.
Right, it's
supported.
modularized as a way we're providing APIs, so there's a single C++ header file and a C++ file where you can use it and provide metrics as if you are providing other metrics for AMD and NVIDIA GPUs.
Yes.
So
that's cool. So a couple of things. One is we are working to get an Intel GPU in the public that people will be able to use, number one. Second is, so you say that you're going to, you guys want to open source this great project.
Yes.
And I wonder if you already have some kind of timeline or if you can discuss the timeline publicly.
I'm waiting for internal code reviews from people like Thomas and Justin. Yeah.
All right. So maybe in a future meeting we'll get an update, because the other thing is, like, you guys don't have to do all the work. Intel people can also try to extend the functionality. Right? Of course, if you are willing to accept pull requests from the community.
Sure. It's probably fine for this module because it's not going to be installed by default anyway.
Okay. Looking forward to see this becoming open source.
Thanks.
Yeah, Christos,
So
go ahead.
Christo, yeah, do you have any questions?
Yes. Hi. Thanks for the presentation. It sounds pretty good. I just wanted you to maybe comment a little bit more on your plan for profiling the internals of the kernels. Is that going to be in the first I guess iteration, or do you plan on doing it later? What is your view on that? Like the instruction sampling, for example, you say in the plan. How high in your priority are these?
Actually, previously, I have done some like duplicated work internally in the old version, so I don't see that's kind of obstacle, at least for instruction samples and some basic binary instrumentation-based metrics. But it's only for NVIDIA GPUs only.
Right. So another very related question, is that going to be only like in your experience and your plans, is it going to be just sampling, or are you also going to be instrumenting the Triton kernels?
We could support both, yeah.
Okay. Right, thanks. This seems really good.
Thanks. Another way to make it more general is probably to instrument at the compiler level so that it's going to be applied generally for all kinds of GPUs.
Yeah. Thanks, Karen. Any other questions for Karen? Okay. So, Thomas, was there anything you wanted to comment about the technical?
No, nothing else. I think just wanted to point out, you already put it in the chat, but I guess a few updates from Phil, where we're going to move to Slack Pro, which will allow us retaining history. The more important update, which I don't have details yet, but we are working on a more formal document to explain how the governance is working in Triton. So that I'm sure that'll be very interesting to everybody in this meeting. But it's, yeah, Phil is still working on it.
Yeah, thanks. Is there any other comment or question from anyone? Okay, thank you everyone for joining. Bye.
Thanks, everybody. Thanks, Kashma.
Cheers, bye.
Goodbye.